As the cruise comes to an end, one last operation remained, recovering the sediment traps that were deployed 5 days ago. During the course of the cruise, we closely followed the drift track in anticipation of their recovery.
Well, we've been out here for the past 5 days training the next generation of microbial oceanographers and making a lot of different measurements. We've looked at activity, how fast the plankton are growing. We've looked at abundance and biomass using microscopes and measuring the carbon content of the plankton. We've also looked at diversity by extracting their DNA, and we're looking at the different species that are present. And why do we care so much about these microscopic organisms? Well, they may be tiny, but there are millions of them in every teaspoon of seawater. Every teaspoon of surface seawater is teeming with this microscopic life. As far as the eye can see, you see nothing but ocean here. And in fact, the oceans cover 2/3 of the surface of our planet. So the activity of these microscopic organisms turns out to have a major influence on the climate and even the habitability of our planet. The issue that we're facing today is increasing carbon dioxide. Now, it turns out that the increases in carbon dioxide in the atmosphere are tightly linked to the processes happening in the ocean. Carbon dioxide in the atmosphere exchanges with the ocean, and phytoplankton in the ocean, through the process of photosynthesis, take carbon dioxide and turn it into organic material. This material is important because it feeds everything else in the food web. But a lot of this material also sinks, and that carbon goes down into the deep sea. So effectively, we call this the biological carbon pump. Carbon dioxide from the atmosphere into the biology and ultimately stored in the deep sea.
One way to study the material that rains out of the surface ocean is to collect it in a sediment trap.
I'm holding in my hands a sediment trap. We had an array of 12 of these at 3 different depths floating out in the ocean for the past 5 days. And it's a fairly simple device, as you can see. It's simply a hollow plastic tube with a cap on the end. When it's deployed, it's open at the top, and it's just out there collecting particles over the past 5 days. Now, this simple device, as simple as it is, can actually tell us quite a lot about the carbon cycle in the ocean. To get these things back on board, we had to pull the ship up close to that free-floating array, come up as close as we could alongside it so that we could throw grappling hooks over the side and hook the lines that were floating at the surface. We then use those lines to pull it closer to the ship. We get additional hooks on it and work it around from the side of the ship to the stern, where we can hook the winch line onto it. And then we use that powerful winch to lift this heavy array up out of the water and get it safely on deck.
With the sediment traps on board, we head back to shore, but the work is not done. All the samples taken during the course of this cruise need to be analyzed back in the laboratory. For the next several days, the students of the Agouron summer course will be working hard to understand microbial processes in the ocean.
So as we move forward and try to piece together how rising carbon dioxide in our atmosphere may influence the future habitability of our planet, one thing we know for sure is that understanding what's happening in the ocean, because of its vastness and the incredible productivity that happens there, is going to be a major piece of that puzzle.